You can start now.
Okay. Good afternoon, everyone. I, Dr. Nidhi Gupta, Assistant Professor, Lady Irwin College, on behalf of OGTC, welcome you all once again to International Conference on Apparel and Home Textiles. The theme for the present session is merchandise. The world is full of gems and diamonds, and we are lucky to have some of them with us today here to build upon this session. With this note, I heartily welcome the chairperson of the session, Mr. Anil Peshavri, who is MD Minu Creations. Mr. Peshavri is a graduate from Sri Ram College of Commerce and a qualified chartered accountant. He started his own garment export industry in 1998 for markets in Europe and USA. His company specializes in young fast fashion. We welcome you, sir. The first presentation.
Please go on.
Yeah. The first presentation of the session will be by Mr. Samir Parial, Director International Tukatech. The theme of the presentation is virtual sampling, evolution or revolution. Now I request Mr. Anil to kindly take over the session and introduce the first speaker of the session to the audience. Thank you.
Thank you, Nidhi. Ladies and gentlemen, this conference of OGTC, I've been logged in since morning, and it's really very useful and informative. The present session is about merchandising and the technology. My 24 years of experience in this industry, one thing is I'm absolutely sure about is that merchandising is the base as well as the backbone of any apparel exporting company. Without efficient merchandising, nothing can be achieved. So I think today's session is going to be very informative. And we have two very eminent speakers with us. The first speaker we have with us is Mr. Samir Parial, who is Director, International Tukatech company. As you all know, the Tukatech is not only a company, but it's an institution itself. Here, Mr. Samir has been working at Tukatech for the past 12 years. Starting his career as a business development executive, he is now Director International at Tukatech. He has undertaken numerous designs, development, and cutting room projects across Asia. A graduate from National Institute of Fashion Technology, New Delhi, his zeal for technology and automation led him to Tukatech, a company that has been known to pivot its own processes and product offerings. I now request Mr. Samir Parial to take it from here and tell us the technology which is being used, which is available for making the most important function as merchandising in any apparel company, how it has been taken to the next level, and how the efficiencies and savings, especially on the sampling part, can be achieved. Mr. Samir, please.
Thank you. Thank you, sir. Thank you for the nice introduction, and a very warm good afternoon to all the members of OGTC and all the people who are attending this conference. My topic for today is virtual sampling or 3D sampling, evolution or revolution. So that's the big question that we're going to speak about today. If I may be allowed to share my screen. Yeah, I think. Right. So virtual sampling, or what the other terms, what we call as 3D sampling or virtual product development, basically evolve around the idea of, I mean, we've all been associated with the garment industry. We all know the processes, so we understand what sampling is. It could be a sampling as an in-house brand. You do your own sampling, or you're being a manufacturer or an exporter, you do your sampling for your buyers. So what is virtual in that? So the first step, which is, once you get a sample request or you get a spec sheet or you get a tech pack, the first thing that we do is develop a sample, which is most commonly called as a proto sample. That's where, instead of doing it physical or doing the first garment as a physical garment, we do it with the help of technology. We do it virtually on the systems and easy to share. So This is just a small introductory video which will make you go through the process of virtual sampling, and then we go on to the agenda, which is the is it an evolution or a revolution?
3D fashion design is a powerful tool to see how a garment will look before it is cut and sewn. Tuka 3D takes virtual product development beyond design and into true 3D fitting. With an engineered design process powered by Tukatech's end-to-end fashion technology solutions, the 3D designer's creativity is backed up by smart technical fit. Tuka 3D models are sculpted from 3D body scan data, capturing the correct measurements, shape, and posture of live fit models. Tuka 3D models are animated with real-time motion simulation to analyze garment fit with movement. Once the 3D virtual model is created, the body shape is flattened to a 2D sloper pattern. The 2D sloper is a tracing of the unique curves and contours of the fit model's body, such as the shoulder slope, armhole, bust, waist, and hip. This sloper will become the master template for all future styles developed for this model. Sloper patterns are generated in Tuka APM for automatic pattern making. Though pattern making is a craft historically passed down by artisans, today's computers can learn the logic of pattern making, so a person of any skill level can create beautiful 2D patterns. The model's measurements are entered into the sloper specification sheet, including seam allowance and grade rules. Tuka APM generates a graded sloper pattern, which is ready to drape in Tuka 3D. The sloper pattern is added to Tuka 3D from the Tuka design system. The pattern pieces are arranged around the 3D fit model, and a seam stitching is defined. As the garment is draped, the 3D sloper fits the model like a glove. Next, she simulates actions performed during a live sample fitting. Real-time motion simulation is added directly in Tuka 3D without the need for another 3D software. The sloper is analyzed in motion with tension mapping views in stretch and pressure mode and can be isolated to the warp and weft directions. X-ray mode applies transparency to the fabric surface to check the balance and ease of the garment. Any styles built from the sloper will fit correctly the first time. After the shapes of the fit model's body are captured in a 2D sloper pattern, the pattern maker only needs to change the ease or style lines rather than start with a new pattern or ill-fitting reference block. The pattern maker draws the style lines directly onto the sloper template and shortens or lengthens the piece to suit the new silhouette. After all adjustments are finished, the 3D operator simply updates the draped 3D sloper to apply the pattern changes for the new style. All changes made to existing pattern pieces are applied without resetting the entire 3D draping process. Only the new pattern pieces need to be arranged and stitched. Because the pattern maker used the 2D sloper pattern as a template, they do not need to spend as much time verifying the fit for the new style. Colorways can be applied by the 3D sample maker in Tuka 3D or by a graphic designer in the Print Visualizer module of Tuka 3D Designer Edition. The simulated garment brought into the Print Visualizer is a blank 3D canvas for prints, logos, or textures. Prints added from the material editor can be scaled on the 3D garment. Designers have a built-in Pantone color library for solids. Designers can take advantage of the Print Visualizer graphic integration if they prefer to create colorways in their favorite graphic design software. They simply create artwork on the flat pattern layout and apply the finished design to the 3D garment surface. The designer analyzes all colorways as a 3D storyboard. They can render the storyboard or individual 3D garments for presentations and sharing. 3D garments are shared to internal or external teams on Tukatech, the web-based digital sample room that connects every person involved with virtual product development to one platform. The process is repeated for every style developed for a brand to maintain a consistent fit regardless of product category.
So that was the process that explained what virtual sampling is. So instead of developing the patterns and then using those printouts of those patterns to make a actual physical garment, we do that virtually on the system. Obviously, the advantages are numerous. We don't have to source for things. We don't have to source the fabric. We don't have to source the trims. We are not dependent upon a sample sewer. We don't have to ship the samples. So just comparing a traditional way versus the virtual way, this is, average aggregate time of the time that is consumed to make a physical sample. Now, this data could vary from company to company, but this is what we've seen after hundreds of implementations, that this is what the average comes out to. Once you receive a sample request, developing a pattern, then sourcing the trims, fabric, or accessories takes about 2 to 3 days and so on. I mean, this is the breakdown of it. So on an average, what we've seen is that company to company takes somewhere about 12 to 20 days to get the proto sample out and shipped, and then receiving a feedback on it. Especially during like what we saw in 2020, made this process much more time consuming, because you were not able to send the samples, and what we used to have as a buyer manufacturer meetings, those weren't happening, people weren't traveling and so on. So that's where 3D really got the boost. And this is what we recommend as a virtual product development. This is the life cycle of a virtual product development. You make a 2D pattern, immediately move it on to the 3D, you make a 3D drape, internally you approve or reject or comment or say these are the changes to be done. Once the silhouette or once the look of the garment is finalized, then you move on to the colorways, which is the prints, the designs, or the colors in which it is supposed to be made. And then instead of sending it as a physical sample, you upload it virtually on a platform, wherein the buyers and the manufacturers or all the people associated can be on one single platform. They can see the style, they can look on the comment, they can comment on the look, they can comment on the colors, they can request any changes. These changes are given back to the factory, they do it immediately. So, and the time comes down to 1 to 2 days. So what we've seen as a traditional sampling method, which takes about 12 to 20 days. I mean, when I say 12, I'm talking about the company with the best possible processes. It has come down to 1 to 2 days with the virtual sampling. So to answer the question where this agenda or the question that was, which is also turns out to be the topic of this presentation, we would definitely say that virtual sampling is an evolution. And at the same time, the ideas or the creativity that has come out from virtual sampling, or the add-ons that have come onto the virtual sampling, or the way the people have been using it, is a revolutionary method. That would be covered in the next part of the presentation, wherein we'll see some use cases where how people have used 3D or the virtual sampling in a revolutionary way. So this shows a evolution. This is a small video that shows the evolution of apparel sampling. This is the old way that we were doing it. Hundreds and hundreds of samples being made. This changed, that changed, because one thing that we all sort of forget or tend this thing is that the designers at the brand level or the buyer level, even when they are doing a tech pack or they are requesting for a sample, they also exactly don't know how the garment is going to turn out. So most of the times we see that the changes that are requested in the first proto are not because of the manufacturer did a defect or did not understand the design. It is basically because the designer who originally had the concept or originally had the idea didn't look, didn't like the final look. Maybe, say for example, if it's a dress, maybe, she felt that it would look good in a half sleeve, but now she feels that, maybe it would look good as a sleeveless garment. maybe the length that was decided, maybe it's too short, maybe it's too long, maybe the print that was decided, it's too small, it's too big, or maybe if I could also see it in a different colorway. So that's where 3D helps a lot in getting these things done quickly. And it is not that we as an apparel industry have been looking 3D, sort of actively since the past few years, but 3D technologies across all other industries have been there since long. On your screen you can see these videos are probably from the 90s. Automotive, real estate, aerospace engineering, they have all been early adopters of 3D technology. No more car designs or car crash tests. They are all done virtually first. Even if you go and if you're getting a house constructed, or if you're buying an apartment, the first thing that you see is the 3D outlook of it, that how it's going to look. And that plays a major deciding role in whether you would opt for that, or you request certain changes, because we are looking at garment here, but imagine something like, a building being constructed. Once it's constructed, it's very difficult to make the changes there. So you need to see it. And since you have the technology now, we are living in an era where technology is right from where we wake up in the morning till the time we sleep, we are all sort of, technology plays a role in everything that we do these days. So that's how it has been. And even in the apparel industry, these are some snippets that will show you that, 3D technology or virtual sampling technology has been there for almost 2 decades now. The adoption we've seen is mostly, since 2020, but there were some early adopters. There were certain companies that were pro-reactive and adopted to the technologies much earlier than. This is a snippet that shows that, what we used to call it as a EFIT simulator or a 3D sample was launched in 2004. This shows you that Tesco, there's a client of ours in Sri Lanka, Hyderabad. They were awarded an excellence award or an innovative award by Tesco in 2007 because they were doing their samples on 3D systems. We even developed 3D sample making or 3D sample viewing available for phones. This is as early as 2007. We started training students on 3D because we knew that this is going to happen. The day would come where everybody would be moving on to the 3D virtual sampling. As we've seen with the other 2D technology, early 90s, early 2000s, there were only a few adopters of even the 2D technology, or maybe it was being used only for grading and marking. But now in today's time, we see that almost, I would say that, 95 to 98% of the apparel manufacturing companies have now fully incorporated 2D, and all the development is happening on the systems rather than using the conventional paper and pen method. Even in India, there were certain companies like we had our first major 3D implementation in 2010. This was a company in Kolkata that were doing workwear uniforms. So things have. The technology has been there. The idea of showing the slide was that the technology has been there. It's almost been there for 2 decades. There have been some early adopters, but now we've seen more and more people being interested into it. This is another video that shows, this was done in 2011, 11 years ago. And this is just to show that, we were able to do this quality of virtual samples even then. Yes, it did take time because the computer technology, the processors, the graphic cards were not of that scale right now. So for example, this is a small video, maybe like a minute video, and it took us 5 working days, and 24/7 the computers were running. It took us that much time to deliver this quality in 2011. But in today's time period, I would say it's easily a 1-day job. So moving on to the 3D sampling or virtual sampling, what are the key components in there? So basically, there are 3 key components. First is obviously your pattern that you develop, because what we are doing here, we are not only doing a design or a look sample. What we are also trying to do is that, we do it in the same scale as, the measurements of the garment should be exactly the same as they would have been of a physical garment. So pattern is something that almost everybody is doing these days, whatever technologies they've been using, but all the patterns are being made on the systems and so on. The 2 other components, I would like to share some insights on the other 2 components, how we manage those, is the 3D model or the avatar or the dummy that you see on the 3D system. How do we sort of develop that? The standard measurements, or when we are going for a physical sampling, the standard measurements are only a few, which at times may not be enough. But once we look at a 3D model, we are covering more than, like, for example, if we are doing a 3D model, we are covering more than 65 points of measurements, which helps us to sculpt an accurate model rather than doing just the guesswork. There are certain ways to do it. This is some of the body scan data that we use. If the body scanning is not available or the modeling agency does not agree for a body scan, in that case, we virtually, we physically measure the model and, take postures, front, backs, and sides, so that we can accurately develop a 3D avatar. Other thing that is very important to do a fit analysis is the motion. Static dummy or a static model doesn't tell you a story, and these 3D models, they can't talk. So how can we analyze whether the garment fit is accurate or not, or how does the garment behave when the person is in motion? Is that we add, motion to these 3D models. There are customized motions available these days. We could do a walk, we can do a squat, we can do a, arms up and down motion. We can, if it's a sportswear, clothes, we can even do like running, jogging, playing soccer, playing cricket, all these animations. So that was for the model. And the third major component that analyzes or describes how good a 3D sample is the fabric that is being used to do that. Because we all know that if the same garment made in 5 different fabrics, the behavior, the fall, the way the garment is going to sort of react when the person is in motion is going to be different. So that's why it's very important to capture all the physical properties of that fabric that was actually supposed to be used, so that the virtual fabric behavior is, almost similar to the physical fabric behavior.
Accurate virtual cloth simulation is key to 3D virtual sample making, so that what is seen on the screen is the same as real life. Because precision is so important, discrepancies, 3D mesh resolution, system specification, and even using different operators may result in calculation errors. To eliminate these variables, fabric testing is conducted by the Tukatech at no additional charge for Tukatech users.
I would just like to pause the video here and just walk back to this part. Now, if you see this part of the video, this is a same garment, talking about the skirt. It's the same garment, the same pattern is being used. It's the same model that is being used for, but the only thing that is different is the fabric properties on all those 4. So, you can see the behavior, that how all 4 of them fall, how 4 of them behave while the person is in motion. Static garment, probably they all would have been look the same.
Measuring weight, stretch, and bend for drapeability. The collected data is entered into the fabric testing dialog where the physical tests are replicated with virtual cloth. The new 3D fabric is then added to the fabric library, which includes hundreds of fabric properties that automatically come with a 2D system. Each 3D fabric captures the unique characteristics of the real fabric trait and fit. For example, contact the Tukatech team.
So this is how, companies have been, these are the 3 main areas that the company has been using their 3D systems or their 3D technology for. First is your e-fit. So, sort of you try to do your fit analysis, whether the sample measurements are being matched, what was requested is actually being made, how well the efficiency of the pattern is. My 2D pattern is, we can do a virtual fit session. You have these heat maps, tension maps that exactly tell you, what is the pressure of the garment on the body, what is the stretch percentage, whether this is acceptable or not. I mean, it gives you all the numbers so that you can decide whether this is, sort of acceptable or not. And since the virtual models are actually based on the real life model, I mean, their measurements are, they're an exact replica of the physical models. This data helps you identify whether there is a flaw in the pattern, or maybe I should make it a little bit tighter, maybe I should loosen it up a bit so that the measurements and the way the garment was supposed to fall, comes out accurately. Second is your e-design. You can do your virtual design. So you can, all the systems, all the 3D systems available these days, they all speak to all the graphic design software such as Illustrator, Photoshop, and all these other programs. So you can accurately do your prints, you can accurately do your colors. There is even the Pantone library is incorporated, so you can pick up the Pantone colors directly without the need to match them. And then you can do all your prints, you can put on any prints, you can scale the artwork, you can do engineered prints and all these. So basically making multiple colorways. And the third is, e-commerce. So e-commerce, when in this case, is a bit different from what we know as e-commerce. It is basically selling to your buyer. So for somebody who's doing T2C or maybe like direct to consumer, for them, it could be on their websites. But for manufacturers, it could also be a platform wherein they share all their samples with their buyers. And they have full controls whether they want all the samples to be available to all the buyers, or they want any particular sample to be available to one buyer only. You can add background images and videos, you can do presentations, you can even on this platform you can even see the garment from all the sides. If it's a double layered garment, you can see it from the inside, outside. You can rotate, zoom, pan, see it from any angle. So this is just an innovative way of how people are presenting their styles. This is where the revolution part of the 3D sampling comes in, or the virtual sampling comes in. That till now what we saw was that what is virtual sampling, what are the key components to make a virtual sample, how do we do the virtual sampling. From this part onwards, we cover that what is the revolution behind the virtual samples. This is basically, you're just presenting your entire collection to somebody without actually sending over those samples and without, even making those samples. You just have all of this virtually. And once anything gets approved or you get an order for somebody, then you go ahead and, start making these things. Another way of how 3D technology is sort of being used, or is sort of revolutionizing the way that we used to work. Now if you can see that this is actually a user case of one of our customers. They've been using this to present different case scenarios to their buyers. Now if you see that this is the same sample, the only thing that changes on the tree is the percentage of embroideries. And since the embroideries have changed, obviously the look of the garments have changed, and effectively the costing of the garment also changes. So, if you get a sample request, you do it as it is, that this is how it was supposed to be. Now you also do it in 2 different combinations. Okay, if you're looking for a better price, we can also do it with a 75% embroidery. This is how the garment is going to look. And if in case, there is a further reduction required, we also have a 50% embroidery option. This is how the garment is going to look. This is how the costing is will come out for that one. You can do like side to side comparisons, left and right, different sort of different silhouettes, different embroidery options, and present these as on your meetings or sort of order booking meetings. You can do multiple colorways. Physically now all these things are very difficult to do, for example, because at times it gets difficult even to source the fabric that was originally requested. And then doing it in multiple colorways, or doing it in different colors or different prints, becomes a challenge, because we've seen over the years the lead times right from a request of a sample to the execution of the shipment, they have reduced over the years, and they keep reducing the number of styles have gone up, whereas the order quantity for each style has gone down. So we need to be quick on our toes in terms of product development, so that we can finalize on the product development, we can get the samples approved, we can get the work done, so that we get more time to do, which is the bulk part of it, which is the actual cutting and the actual sewing and actual packing and finishing of those shipments. You can do any engineered prints, you can have prints, and this is how this is the level that we've reached today. You can even look at the quality of the threads. You can even do, like, for example, any prints. You can even sort of distinguish that what kind of printing is being done depending upon the artwork that we use. Again, side by side comparisons. This is how it's going to look on a solid, this is how it's going to look on a sort of, what you call as a checked fabric. This is how it's going to look on as a plain white solid t-shirt. So these are sort of, these ideas have revolutionized the way in which companies have started using 3D, or, started getting a leverage or an advantage over their competitors, that, they can present all these scenarios without actually even making them. You can do denims, you can do different washes, you can do different trims on a denim, different type of buttons, different types of zippers, and so on. You can even, like, this is again a user case. This is not done by us. This is done by a user, where they presented their entire line as a virtual, what you call a virtual show, or virtual fashion show. And then, so we saw that, how companies have been using it, and, what ways they have sort of made use of this innovative technology to streamline their work processes and to gain advantage, over their sort of competitors, not only within the same geographical regions, but, even like competing with our neighboring countries, or all the countries that are sort of more into manufacturing. The last thing, or the last revolutionary, actually the second last, sorry, the last, another thing that I would like to, throw some light on is that now you've done your 3D samples, you made those 3D garments. How do you sort of collaborate and share those samples? Because, these are cumbersome files, these are big files, you can't share them over emails and stuff. There are platforms available wherein you can sort of, showcase your collections, or do a virtual collection available to, all the people that you work with, or all the people that you work for.
Tuka Cloud is a patent pending online.
So for that, what the solution that we have, this is what we have as a sort of collaborative tool or solution. No matter any 3D system that we've been using, you will find similar platforms. This is just to show you that, how you can collaborate, or how you can work with the brands that you work for in a better and efficient way, so that everything, every data, you get to see what's happening with the sample at every step, what about the comments received on it, and your library of virtual samples is also being developed simultaneously.
Sample room that redefines LM from product lifecycle management to process lifecycle management. Approving garments is the longest process in the product development cycle, but with Tuka Cloud, approvals can be made faster and more efficiently. Virtual product development has helped brands, retailers, and vendors to reduce the amount of time and resources needed to create prototypes of their latest design. But now that product development is happening virtually, the fashion industry is faced with new challenges: organizing, managing, and sharing digital data and communication. Tuka Cloud empowers those who create fashion virtually, connect digitally, and collaborate globally. This online digital sample room is more than a software application. It's a product development solution specially designed for managing virtual samples developed in Tuka 3D. In Tuka Cloud belongs to a team. Collaborating within and between teams is easily controlled and managed so that you only see what's important to you. Not only does this intellectual property secure, but it also ensures that you aren't bombarded with the on long email chains. Data and information for every style is kept in sample folders. These folders are sorted into searchable pages and categories, so you can always find what you are looking for. Version control is built into Tuka Cloud. So if your design went from A and you want to go back to B, you can pick up right where you left off. View technical files or download 3D assets to edit colorways in the Tuka 3D Designer Edition visualizer. You can also view motion videos in color, tension, and X-ray mode to analyze fit and aesthetic. A 3D viewer enables you to rotate, zoom, and pan a 3D style without downloading any software. Comments for the style are contained in the same folders, conversations connected to the sample. Notifications are sent automatically, so if something goes wrong or right, you'll know instantly. Track team progress with the analytics dashboard and analyze the progress of individual styles to estimate how much time is spent on a 3D product development process. Make better decisions based on the pulse of where your virtual samples stand. Approved styles become verified digital assets, which can be used as templates for future designs. When the whole team works from the same data, garment design and fit expectations are much clearer. This reduces the need for long tech tags and using email. Tuka Cloud facilitates collaboration between creatives and creators by visually connecting the product development process under one digital roof. Tukatech is a trusted technology partner with numerous brands, retailers, and vendors. Talk to our product development experts.
So this is the process engineering that comes with the 3D and associated processes that come along with it, uploading the samples on a cloud so that your buyers can see those. This is the process engineering. Everything happens internally first. We have internal auditors, we have internal approvers, which get to see the work in progress, which is visible to the connected teams. We can have merchants, we can have designers, we can have sampling people, we can have fabric people, all the people being involved so that they can do their approvals, rejections. If there is a change required, it goes back to the WIP and then it moves forward. And only when everything is being approved internally and then shared with the buyer and then approved externally, then we move on to the pre-production phases of the cycle. One last thing that I would like to share with all of you is that we all know we have all been exploring 3D for the past, at least for the past couple of years. We know that the technology is, it's not a cheap technology. It's an expensive technology. One license, costs. There is a substantial cost involved. What we've seen traditionally is that the 3D samples, if you're doing colorways on the main system, they take time. And they take up time. They take up time of the operator. They take up time. They take up computer time. So another, sort of a module that we developed was a designer edition, which is that, once you have a 3D silhouette, which you can either purchase or you can develop it using your main 3D system. And then we float these licenses across to all the designers so that they can all do all their print combinations, color combinations, without actually touching the main system, and then using their favorite graphic design tools like Adobe Illustrator, Adobe Photoshop, and thus just imposing all those prints on the 3D garments to create line sheets or what we call colorways.
Flat sketches tell a flat story. Bring your ideas to life with simple design tools in the connected world of Tukatech. In the new design room, designers never have to touch a pattern or drape a 3D garment. Instead, they use Tuka Cloud to browse their library of approved 3D assets, examining the drape and fit until they find the perfect silhouette for their new concept. In Tuka 3D Designer Edition, designers apply their own prints to the selected 3D sample, experimenting with all over prints and motifs. These prints are shown at real scale on a lifelike 3D sample, so designers have a better picture of how their ideas will really look when executed. Snapshots from Tuka 3D Designer Edition give a new dimension to line sheets and presentations, bringing ideas to life with the power and ease of 3D design. Powered by Tuka 3D and Tuka 3D Designer Edition.
Yeah, so that was what I had to present today. So just to sum it up quickly, in 15 seconds, virtual sampling is an evolution, but the way that it is being used, or the associated tools or accessories or sort of add-ons that are coming onto the virtual sampling or the 3D world have been revolutionary. That is all what I have to say today. Thank you so much for listening to me very patiently. If there are any questions, I can take them now.
Thank you, Mr. Samir, for such an insightful session and taking us through this virtual 2 to 3D sampling technique. And it was indeed very interesting, and I'm sure this is going to be a revolution in the garment production industry. We do not have any questions for this session, so I now request Mr. Anil to kindly conclude this presentation. Over to you, sir.
Thank you, Nidhi. Thank you very much, Samir, for a wonderful, wonderful presentation. I'm sure most of our delegates who are not using this technology till now would be really encouraged to use it. And from my own personal experience in my company, I can assure everyone that from the time we have started using 3D, we are saving a lot of money, a lot of effort, and a lot of manpower, especially in our design department. And the level of designing has really gone up because we can do whatever we want. And just to make one point addition here, Samir, since morning, all the sessions, one consensus point which emerged was that the whole world is moving and moving very, very fast towards sustainability.
Yes.
So I think one of the biggest advantage that 3D technology has brought on table is that this wastage of hundreds of thousands of samples that we've been making, by not making that, that itself will be a great step towards the concept of sustainability.
Absolutely,
So
sir.
again,
You are absolutely right on the point. There was a video that I showed earlier, which showed, hundreds and hundreds of samples lying around and eventually of no use. With 3D, we have sort of got them down drastically. There are no variations or iterations of samples being done. So yes, this is a great tool in, looking at it from a sustainability view of, sustainability viewpoint as well.
Yeah, thank you. So our
So-
next eminent.
Sir, thank you, Mr. Anil. I now request all our delegates to join the session again for the next presentation of this session by Mr. Sonal Jain. Thank you.
All right. Thank you so much. Thank you, everyone. Bye-bye.
Once a lot.